Now let us check our master method type 2 set of problems. If I am having an equation such as Tn is equals to a Tn by b plus f of n, such that my f of n is in some form like n raised to the power of k log Pn, then we first find log a base b. Then we compare it to the value of k. So the k value is over here. If this log a base b is greater than the value of k, then we execute first case. If this value is equals to k, then we execute the second case. If the value is less than k, then we check the third case. Now in the second case, when my log value is equals to k, we again check the value of p. The p value is over here. So if my p is greater than -1, then this is the time complexity. If the value of p is equals to 1, then this is the time complexity. If the value of p is less than -1, then this is the time complexity. Also, if the value of log is less than k, then also we check the p value. For p value greater than equals to 0, this will be the time complexity. And for p value less than 0, this will be the time complexity. Let us check out our first example. This recurrence relation, if I write it to some standard form, this becomes Tn is equals to At n by b plus n raised to the power of 1 into log raised to the power of 0 into n. So over here, the value of a is 4, the value of b is 2, the value of k is 1, and the value of p is 0. So according to my step 1, first I'll calculate the value of log a base b. So according to this specifications, I'm having the value of a as log 4 base 2. This can be written as log 2 raised to the power of 2 base 2. This makes the value as 2. In this second step, I have to check the value of log a base b as if it is greater than k or less than k or equals to k. So I can see over here, my k value is 1. So the log a base b value is greater than 1. So this is my case 1 problem. So the time complexity is theta of n log a base b. So the value becomes theta n log a base b was 2. We have just calculated. So I can say the time complexity is theta of n square. Let us check out our second example. In this recurrence relation, if I convert it into some standard form, the value of a that I'm getting is 4, the value of b that I'm getting is 2, the value of k is 2, and the value of p is 0. So now let us calculate our step 1, where the value of log a base b becomes log 2 square base 2, which is equals to 2. My log value is equals to my k value. So this resembles my case 2. As an addition step, we also have to check the value of p. So over here, the value of p is 0. The value of p is 0. It implies that the value is greater than -1. So the time complexity will be considered as this one. So I can say the time complexity for this function is theta of n raised to the power of k log raised to the power of p plus 1 into n. So this becomes theta n raised to the power of 2 into log raised to the power of 1 into n. So this is theta of n square log n. Let us consider another example. In this recurrence relation, my equation is Tn is equals to 40n by 2 plus n square log n. So the value of a over here is 4, the value of b is 2, the value of k is 2, and the value of p is 1. So now if I'll calculate log a base b, this will come as log 4 base 2, and the value will be equals to 2. If I check this value with my k value, so the log value is equals to k value. This is my second case problem. Now as an addition step, I have to check the value of p. So over here, the value of p is equals to 1, which is p greater than equals to 1. So I can say the time complexity for my this function is theta of n raised to the power of k log p plus 1 into n. So this becomes theta of n raised to the power of 2 into log p, that is 1, so log square n. So the total time complexity that I get for this recurrence relation is n square log square n. In this example, my recurrence relation is Tn is equals to 2Tn by 2 plus n by log n. So I can also write this statement as n into log raised to the power of minus 1 into n to resemble it in this form. So let us check with a standard form, or let us compare it with a standard form. So the value of a becomes 2, the value of b becomes 2, the value of k is 1, and the value of p is minus 1. If I see my log a base b, this becomes log 2 base b, so the value is equals to 1. If I compare this value with k, this becomes log value is equals to k, which is equals to 1. So this resembles my case 2. As an additional step, I also have to check the value of p. So over here, the p value is equals to 1. So this resembles my case 2 second option. So the time complexity of this function is theta of n raised to the power of k into log of log n. So the time complexity becomes theta of n into log of log n. Now let us check out this recurrence relation. So the recurrence relation that I am having is Tn equals to 2Tn by 2 plus n by log cube n. So I can write this equation as n into log minus 3n to compare it with my standard equation. So the value of a that I'm getting is 2, the value of b is 2, the value of k is 1, and the value of p is minus 3. So getting my a log a base b values, this becomes log 2 base 2, the value is equals to 1. We have to compare it with the value of k. As the value of k is also equals to 1, I can say this is my case 2 problem. As an additional step, I have to find the value of p. So over here, p is equals to minus 3. So I can say that the p is less than minus 1. So this resembles my case 3 over here. Sorry, case 2, equation 3. So the time complexity for my function would be equals to theta of n of k. So the answer becomes theta n raised to the power of 1. So the time complexity for this recurrence relation is n. Let us consider this example. So the recurrence relation over here that I am having is 2Tn by 2 plus n square log n. Comparing it with my standard equation, the value of a becomes 2, the value of b becomes 2, the value of k is 2, and the value of p is 1. I have to calculate my log a base b. This becomes log 2 base 2, the value is equals to 1. I have to compare the value of my log with the value of k. Over here, I see the value of k is equals to 2. So I can say the log value is less than k. This resembles to my case 3. And now I have to additionally check the value of p. So the value of p over here is 1. So case 3, equation 1 satisfied this equation. So the time complexity that I would be getting for this recurrence relation is theta of n raised to the power of k into log p into n. So total time complexity becomes theta of n square into log p value is equals to 1 into n. So this is the time complexity for the recurrence relation 2Tn by 2 plus n square log n. Now let us check our next recurrence relation. This is Tn is equals to 2Tn by 2 plus n square log n. So I can write this statement as n square into log minus 1 into n to compare it with my standard equation. So the value of a becomes 2, the value of b becomes 2, the value of k is 2, and the value of p is minus 1. Let us find the value of log a base b. This becomes log 2 base 2, the value is equals to 1. We have to compare my log value with my k value. Since the value of k is equals to 2, my log value is less than k. This resembles my case 3. Now we have to additionally check the value of p. So the p is equals to minus 1. This resembles my second equation in case 3 where the value of p is less than 0. So I can say the time complexity for this recurrence relation is order of n raised to the power of k. So the value of k over here is 2. So the total time complexity we get is order of n square.